Hello and welcome to this repair tutorial, and today we're going to look at a Cambridge audio, and the model number is AM5 and this is part of the Topaz range. This amplifier was released around about 2010, and in terms of general specifications, the power output is 2 times 25 watts into 8 ohm connected speakers, and the frequency response is 20 Hz to 20 kHz, with a total harmonic distortion coming in at 0.15%. And then in terms of inputs, you have DB/DVD, CD, tuner, also DAB connection, and because this is the AM5, you also have the ability to connect via the right hand side jack socket an MP3 player or any other auxiliary device. Now, Cambridge Audio categorised the AM5 with the AM1. The AM1 is slightly lower powered, coming in at 20 watts per channel. The AM5, you have a record output. And in terms of dimensions, we're looking at 430mm wide by 340 deep by 880mm high. And then weight is 5.1 kilograms. Now this amplifier I would regard as an entry level. So it means that it doesn't have some of the higher level features that you would find on a more expensive amplifier. But nonetheless, the audio quality delivered by the amplifier is good. Now, what was the issue with this amp when it came into the workshop? Well, not a very complicated repair. The fault, as you can see here, is that the power button is switched on, but the power LED indicator remained off. Now, your first initial check, of course, is to verify is there indeed power coming into the amplifier, making sure that there's not a fuse which is open circuit, or maybe that the primer of the transformer has gone open circuit, but that was not the case. AC was coming into the amplifier, rectified, and the correct DC voltages on the board. So that simply meant that you had an issue then with the LED indication. This photograph here, you can see the rear. So the LED just goes into a small plastic former, and that former is designed such that the LED will protrude through the small hole in the front bezel. It's a 3mm LED, blue type, which has been inserted, and they've used like an epoxy resin just to hold it in place and seal it. And then via the two cables for your plus and minus power supply, it plugs directly onto the board. Now, extraction of this LED is very easy. What you have is just a single fixing screw, and what I'm showing you here is this plastic moulding, and then what I've done is I've pulled out the small LED. And just verification, before you sort of started to remove the LED, the first thing that you have to verify is just make sure that you've got the voltage which is on the 2-pin connector. So here we had the voltage, it was present. So then the next course of action before removal was just simply to unplug it, and then you can use your multimeter leads, put your meter onto diode test, and then you can verify if indeed the diode is open circuit or not. Normally with a multimeter, it depends on the drive voltage. Often with LEDs, you can normally illuminate the LED. Okay, not at full brightness, but enough to indicate that it's working. Here, as I said, you can put the multimeter on, test both ways, and the LED was open. So really a straightforward repair from that perspective. So here we just show you a replacement blue LED. This is a 2-volt device. And then if we just step forward a moment and then do an extract from the service manual, what you can see here on the left hand side is where it shows the AC power coming in. You have the required suppression component across the switch, so that just reduces electrical noise. Then you have the inline protection fuse. What they're not showing you in the service manual is the EI type transformer. Now, this amplifier is very, very similar in design to the A1 series, and that's the Mark III. On the previous versions it uses a toroidal transformer, but on the latter version it didn't, and they've carried that through here. The design itself is not fundamentally different, and then here what I'm indicating is that once it comes off the rectified voltage, you can see that the VCC of the negative and positive supply goes via a drop-in resistor. There's a small capacitor in place, and then the LED, as we saw earlier, just plugs in. Also, as well, on this extract, you can see two other parts of the circuit as well. On the lower side is the power for the plus and minus 15 volt supplies, and that will be used in the preamplifier and the tone circuit controls. And again, as we've covered in other tutorials, you can see that there is both rectification, so this is 4-wave rectification off the secondary of the transformer, but then you also have the electrolytic capacitors to provide the smoothing and removal of that low frequency noise. And then you also have the smaller disc type capacitors or ceramic capacitors, which are then used to remove the high frequency noise. And then after that, it goes through 2 current limiting resistors. And then what they've done is they've just used 15 volt Zener diodes for the positive and negative supply. And good practice is, after the Zener regulation, they put in some additional filter capacitors, just to ensure that the voltage provided to the preamplifier stage is as clean as possible, because anything that enters into the amplification stage, of course, in terms of noise, will be amplified up. And then what you're also seeing as well, there is a mute circuit, but we'll come back to that in a little while. All we're simply doing there is it just monitors the voltage supply on the negative rail, then provides a voltage then going into the mute pin on the main power output audio device. Now I'm showing you here after the LED has been repaired, and you can see that it's illuminated, but there's also some additional information which we can share with you, which just gives some more sort of insight. So when you look at this photograph, what you can see are the bass and treble control potentiometers. On the left hand side is the volume control, and it's mounted on these taller leads. And then you can also see as well the rectification diodes, and then the two large power supply filter capacitors. What they've done is they've used this sort of brown bonding glue, but in this case this bonding glue wasn't touching any other components. So in the future, when it does actually dry out, and it will probably follow the same format as all of this brown glue that was used around this time period and before, where it becomes conductive and corrosive. And then also as well, what you can see is that there is the protection fuse, which is just underneath the fuse cover, which is the green one. And as I said, just behind the power switch is the suppression. And then if we step into the circuit diagram, what you can see here is both the preamplifier and the tone control circuits. So on the left hand side, as we're looking in, you have an additional circuit just towards the top part, which is the jack socket for the MP3 player on the AM5. On the AM1 you don't have that. And then after the mechanical switching, it enters into the preamplifier stages. And of course they're identical because you have a left channel and a right channel. Now, the preamplifier operational amplifiers are JRC, so that's Japanese Radio Corporation, so a very, very well-known and respected brand, 4558. For this amplifier, being entry-level, you don't have the ability to switch out the tone control circuits. So once the preamplification has taken place, it then passes to the tone control. Here, same operational amplifier, so these are dual operational amplifiers, so 2 amps within the same package. People may well ask, well, why do they go down this route of using an integrated circuit rather than discrete? A number of reasons. First of all, cost, because they can reduce the overall cost, but also as well, because it's an integrated circuit, then you also have excellent thermal stability within the device, rather than maybe using individual or discrete transistors where you have to sort of back-to-back them, put some heatsink compound in between so they get the same temperature gradient, and then normally there's some kind of encapsulation on top. And then what you can also see is 2 sets of potentiometers. So you have the dual gang potentiometers, which are then used for the left and right, and then they are then adjusting the resistance, of course, within the feedback network, connecting then to amplify up more of the higher frequencies. And then you can see the other potentiometer there, same for the bass. Now, what I've always found with these Cambridge amplifiers, when you sort of adjust the treble control or the bass controls on these units, it's a very subtle change. On other manufacturers, and let's take an example like Kenwood, when you adjust in the bass controls on those types of amplifiers, you really hear a significant difference. Same with Techniques. And then what happens after the tone control circuits and the preamplifier stages, it then just passes through here to the volume control potentiometer. And that was our potentiometer, which had the longer lead, so it sits a lot higher than bass and treble controls. And then after the attenuation, that signal then is delivered through to the power output stage of the amp. So here what you can see is an aerial view or a top shot of that. The actual audio output device is a dual type, so that means it is handling both the left channel and the right channel audio output, and it's mounted on this heatsink. So if we look in a little bit more detail here with the schematic, what you can see is that Cambridge Audio selected to use an LM4766 audio output IC. But just to provide some sort of more insight with regard to this amplifier doesn't have a speaker protection relay. So what you will not hear is after maybe 4 to 5 seconds after the amplifier is powered up, you're not going to hear a click because there is no electromechanical relay which is sensing, for example, no overvoltage situation, and then will operate to connect the audio output from the amplifier to the connected speakers. So here, what is this package? Well, it's available in two versions. The version that you see in here is the non-isolated type, and that means that that metal tab will be mounted directly onto the heatsink, but electrically it is connected to the amplifier inside of the package. You can also purchase the same device, but then it is fully plastic encapsulated. So you can see here for the non-isolated type, the maximum output per channel that this device can deliver is 40 watts. But for the insulated type, that reduces down to 30 watts. And then for connected speakers of 8 ohms, then you're looking at a total harmonic distortion of 0.1%, and that's for a continuous average output power. But this device has additional features, which is very common. Manufacturers produce these ICs, they will literally make them in the millions, and they will be used in many different audio devices. And again, similar to what we said about the preamplifier and the tone control circuits using these integrated circuits, this avoids the requirement for a lot of discrete components to provide the same output power. So a single off-the-shelf package, and as with all component manufacturers, Cambridge Audio would have looked at the data sheet, and they will give examples of circuits and the correct way in which that circuit would be designed. So here you can see that we have the input coming in to the left hand and the right hand power output stages, and then of course the level of that signal will be dependent on the volume control. And then once it passes out of the amplifier stages, you can see that we have two inductors which are in parallel then with the resistors, and then it then connects directly to the speaker output terminals. So as we said, there is no speaker protection relay. Well, that brings about the point that normally with older type amplifiers that had no form of protection circuit, the relay also had a secondary use, not just for protection. They would leave the 4 to 5 second delay, which would enable the amplifier's power supply rails to go up to normal operational value, and that provided really noise free. So when you powered up the amplifier, you didn't hear the charging up of the power supply capacitors or rail capacitors, and also as well when you turn the amplifier off, it was the same in return. You didn't hear the decay as the voltage and the current then collapsed as the power went off. And then you would hear that again as a transient noise through the speakers. So what they've done here within the device is that you have additional pins and additional functions. And on the earlier part of this tutorial, I referred to the mute. So here you can see that there is a dedicated pin on the audio output IC marked as mute. So here what they do is that they will then connect these two terminals together, and that in turn will then go back to that small circuit which is monitoring the voltage coming in on the negative rail. So the reason for that is if you're able then to mute the amplifier, it's in effect acting really the same as a speaker protection relay from a noise powering up and powering down point of view. So we refer to this, and again Texas Instruments have used the same terminology, it prevents what we call clicks and pops coming through the speakers. So the operator, of course, or the user of the amplifier is going to be irritated by the noise. And then it also has under voltage built into the IC. So the under voltage, what it's actually measuring here is that when you power up the amplifier, before the amplifier reaches the full operational value, what it's looking to do then is to prevent any DC spikes. And then when you depower the amplifier, what will happen here is the circuit internally will effectively bring the outputs then back down to ground immediately. So again, you're not going to hear the DC noise through the speakers in either direction. Now in terms of over voltage, it can limit the maximum current, which is 4 amps peak, but it also has a voltage clamping circuit. And then as with any device, particularly on audio where you need of course to run it and it will generate heat, you will always have some form of thermal overprotection. So what is happening here is that if the amplifier audio output IC gets excessively hot and reaches a temperature of 165 degrees Celsius, the audio output device will shut down. Then of course the temperature would then begin to fall, and then when it reaches approximately 155 degrees, then the output stage will then switch back on. But what Texas Instruments have done here, and if you refer to the data sheet, it will provide you with more information because it's quite detailed with regard to how that thermal protection works. It's not simply like an on-off switch where the two temperatures are reached and it either turns off and then turns back on again. It also looks at the temperature rise, how quickly that temperature is increasing, and then will take the appropriate action. So as I said to you, not a complicated repair, but again the opportunity just to provide some more insight with regard to this entry-level amplifier. So after the LED was repaired, we do the normal thing, so we just check operation of the amplifier. In this shot you can see the EI transformer on the left hand side, and the user controls are also cleaned as well. So this is the bass treble balance controls, also as well the input selection switch and the MP3 jack socket as well, so we just use De-Oxit for that. So that really brings us to the end of this tutorial. So as always, I really appreciate you stopping by. And if you need any help, guidance or assistance, by all means email audioamplifierservicing@aol.com and I'll be more than happy to come back to you and provide any guidance or assistance you may require. So until the next time, all the very best, cheers and bye bye.